Oh, it will take a long time. You will have to count it in several seconds. In fact, maybe even in minutes.
Right.
Because it's 1.5 million kilometers away.
So how does ISRO track this Aditya craft that is to be 1.5 million kilometers away from the Earth?
We have a deep space Earth station at Bailalu, and we also have arrangement with a lot of countries who have these kind of facilities, and we work in a cooperative arrangement with them so that we are always linked to the satellite. Eric?
Professor Arup, missions to study the sun are undertaken predominantly by NASA, European Space Agency. Why?
Well, even China and Japan have also sent in solar satellites for solar observation. So India is just joining the same club. Why? Again, the answer is the same. We need to understand more about the space objects, and in particular the sun, which gives us the wherewithal of life.
Okay. Professor Arup Dasgupta is a former Deputy Director of ISRO from Ahmedabad. Professor Arup, stay with me because it's now under 40 seconds until the launch. We'll go live to Sri Harikota and listen in.
Timer. T-minus 1 minute and counting. Minus 55 seconds.
All stops around.
Minus 50 seconds.
All sequences armed.
तो हमारे साथ बने रहिए. अब 40 सेकंड पर
Minus 40 seconds.
प्रमोशन किया जाएगा.
VSPP open.
Minus 35 seconds. Minus 30 seconds.
Real-time programs activated.
Minus 25 seconds.
PS2 VSPP open.
Minus 20 seconds.
PS1 ignition RMS arm.
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking.
P3 tracking.
Magnificent lift-off of PSLV C-57 with Aditya L1 on board.
Plus 15 seconds.
PSLV C-57 का सफल उत्थापन और इसके साथ
20 seconds.
प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के तेज से विज्ञान को प्रकाश करने.
Air lead strap on ignited.
इसके साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का. आप देख रहे हैं PSLV C-57. प्रथम चरण पूरी तरह सामान्य.
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday sky. A rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here, adding to this, the thrill, are just amazing. Ground lit and air lit strap-ons operating together with the first stage, S-139.
Ground lit strap on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रैप ऑन को सेपरेट कर दिया गया है और प्रथम चरण का निष्पादन सामान्य है. इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा.
Air lead strap on separated.
जी हाँ, इसकी भी पुष्टि हो गई है. स्ट्रैप ऑन को सफलतापूर्वक पृथक कर दिया गया है.
We are 100 seconds past the launch time. The ground lit and air lit strap-ons have been separated. S-139 motor still thrusting.
S-139 110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है.
Plus 2 minutes.
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद उत्पन्न कर रहा है.
The launch vehicle is at an altitude of 73 kilometers. First stage has been separated, second stage has begun its operation, and the closed loop guidance has been initiated. According to the announcement by Range Operations Director, PS2 is developing nominal thrust.
PS2 41 टन के तरल नोदक पर आधारित चरण है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150 सेकंड का होगा।
Shar and Port Blair tracking stations presently acquiring.
And there you go, Aditya L1
Flight path closely
is on its way to the sun after a successful blast off from the PSLV XL rocket, which is carrying the Aditya L1. It has blasted off to the sun, and the experiments and the observations begin. So we are still observing as this rocket goes to space in a matter of minutes now. I think we're in the third phase. This is, yes, indeed, that's the third stage of the rocket launch until the Aditya L1 is released to space and it starts orbiting the sun and observing the sun. Professor Arup Dasgupta, as a former deputy director of ISRO, he's still with us. Professor, the launch has happened. What next?
Well, we have to wait because this is a fairly complicated launch. Initially, the satellite will go around the Earth in a highly elliptic orbit, much like what happened in Mangalyaan as well as Chandrayaan 1, 2, and 3, because it has to pick up speed. Right. So as it goes around the Earth, when it reaches nearest point of the Earth, which is the perigee, the motor will be fired and the orbit will be further raised until, in this particular case, it moves out of the sphere of influence of the Earth. So it is called the SOI, the sphere of influence. And then it will be heading towards the sun. And then through a very complicated set of maneuvers, it's not going to go into an orbit right around the sun, but it will actually come to a position called the L1, where it will be located in what is called as a halo orbit. So it will be going around the sun. So it will always be between the Earth and the sun, but it will be in a very small orbit called the halo orbit around this point, which is called the Lagrange point 1. Eric?
Professor Arup, we are seeing scientists keenly observing the launch. Probably you can tell us the crucial stages of this launch. And I can see we have stage 1. How many stages are there? And what's the crucial stage of this launch?
Well, all stages are crucial. Currently what I see is that the fourth stage is firing. So the fourth stage will fire twice. There are 2 coasting phases also. So the fourth stage will fire once for a length of time, and then it will allow the whole system to coast for a period of time, and then again it will switch, and again it will power on. And once it powers on and attains the velocity which is required, it will shut down and separate from the payload. So the payload will be on its own. Of course, the payload also has its own rocket motor for further use later on in the journey. And this journey is going to take something like 4 months.
Yeah, 100 days.
100 days, out of which it will be around the Earth for 5 days. And then after the 5th day, most probably it will leave the sphere of influence of the Earth and then be on its own, on its way to the sun. Eric?
Professor, why can't solar studies be done from Earth itself? Why do you have to go closer to the sun to find out?
Because the Earth has an atmosphere, and that atmosphere actually absorbs many of the solar radiations. Earth also has a a magnetic field, and the magnetic field actually deflects away many of the radiations which are coming from the sun, the solar wind. So therefore, you need to be away from the Earth's atmosphere and magnetic influence to be able to observe the sun better. Eric?
Professor Arup, just for the benefit of our viewers, now that this launch has happened, when do we know that it is indeed a success? Or how do we know that it is indeed a success?
Well, it has to achieve its position at the Lagrange point, and then its sensors will be switched on one by one. The data will be coming back to Earth, and then from then we will know whether the sensors have survived this rather long journey. And what the results we will be getting from the sun, we will be able to understand that everything is fine and the mission is a success in putting the satellite into the desired position.
Right.
The analysis of the data will take its own time. So, as you said,